G'day, it's Robbie again. Well, I finally got a bit of spare time and I can get on with a bit of hobby work. And the first cut off the rank is going to be a Stirling engine. I've been wanting to make one of these for a long time, and I've played around with this sort of stuff for years, but over the last 10 years I haven't done anything in this line really. Anyway, this is what I'm going to make up, something similar. This is a Banggood Stirling engine. These are some photos from the Banggood site, and it's just that little twin piston thing, or displacer and the other compensating piston, I suppose you call it. It looks pretty neat, and it shouldn't be very difficult to make this really. I got these photos off their site. This one drives a little generator, can you believe? How cool is that? Yeah, I think it was only about, it wasn't very much, I think it was only about like 40 bucks or something like that. It was cheap, for, you know. As you can see, yeah, it's got, you can get some sizes here. Mine will be probably a bit longer than that, but that's what we're looking to make. That's where we're headed. So, what to do? Well, first thing is to see how the this piston here, which I'm going to do in glass, how that's going to work in. And Craig Group sent me a couple of air pots. And these are really neat things, beautifully made, and they can be used as a dampener. See, they've got a graphite piston, and you can use that. So that I want to use as this piston here. So I'm going to have that there, and then I'm going to make up in glass, and then I'm going to make up a brass, out of brass, the displacer over here. So basically, you know, looking down from the top, and then you're just going to cross-link them. Should be pretty easy, because you just have a piece of brass here, and they'll just breathe, you know, one into the other, and then have a longer crank throw on this one. Yeah, it all should all work out pretty neat, I reckon. Okay, all pretty simple. I mean, these are real good, you know, the way they make them are beautiful. Now, so first thing is I thought I'd better check the tap on this, the thread on this, to see what size it is. And this is where you get your first surprise. It's nothing like any tap I've got. It's actually 3/8 ME. It's a 32 TPI 3/8, which is very unusual. I have to look this one up. So it's ME is actually model engineer thread. So as I haven't got a tap, and I'll definitely need a tap to do the threading, either buy one if you can get one easily. I know you can get them off eBay, but you know, and they're not cheap. You know, you're talking, you know, $13, $14 for one tap, or a set of three for about $35, which is normal. You know, that's the sort of prices you pay for taps and high-speed steel. So I thought, screw it, I'm not going to bloody pay that. I mean, I'm tight, as you know. Yeah, I'm pretty tight. So if I can make it, I will. So I made one. So here's the thread. Here's the tap here. It's no work of art. It's a bit. No, it's okay, I suppose. But anyway, for anybody that doesn't know how to make a tap, they're really, really simple to make. And basically, all you have to do is get some steel, which is hard steel. But it has to be able to be machined. So I used a form of 1080 spring steel here. It's not as springy as some spring steel, but it's so springy, it's hard enough that you can't machine it without annealing it. So basically, you know, heat it up red hot, let it air cool, and then you can work it. And then after you've done your machining and everything to your satisfaction, heat it up to red hot and drop it in a bucket of water, and she's hard again. That's the simplistic way of doing it, and it works fine. So I'll come in close on my little tap here. So as you can see, all it is you've machined the steel down to the correct diameter that you need. You've cut a 32 TPI thread in it with a single point cutter. You then slotted it with a slotting disc, and I just used a Hilda any rotary tool will be okay. I've put 4 slots in it. A normal tap has 3 slots. You can make them as wide as you want. All they have to do is give you some clearance. By having 4, I mean, this is, you know, it's a bit rough and ready, so don't get too carried away with this, but it works. Yeah, by having 4 slots, it gives you 4 cutting edges. So it should theoretically cut a bit better than 3. And when you do cut the slots, you undercut towards the direction of rotation, so not straight down at 90, just cut it back on a bit of an angle, and that will give you more of a curve edge. And yeah, then just heat it up, drop it in the water, and she's good to go. And just put some flats on the end. Does it work? Well, of course it works. I made it, it has to work. So here's a bit of aluminium, scrap aluminium, that you can see I've played around with, drilling and tapping into it to make sure that I got it right. I had to have 2 goes at doing this because there's a couple of things you have to be aware of. So this is just some scrap. Here's our little air pot. And she screws in. Look at that. Perfecto. Yeah, no problem whatsoever. And you know, I think this one over here also was the correct size. Yeah, this one's a bit more snug. Yeah, that's better. That's the best of the lot. So I use a different size drill on that one. So there you go. Yeah. Well, it's going to go that way, isn't it? Cool bananas. So there you go. Yeah, you can do your own taps. Easy. And, I mean, these are really meant for soft metals like aluminium, copper, brass. Well, brass I should have said. I'm not going to be using any copper. You could use them on steel, but they probably would lose their edge fairly quickly. I've made these in the past for one-off jobs in alloy. I've never ever made one to use on steel, but generally working on stationary engines and stuff like that, you know, which are aluminium, I've had to make up studs and stuff, and yeah, put in bigger studs, and you haven't always got the right tap, so that's it. That's the name of the game. So what could possibly go wrong making this while I've got all these extra holes here? Well, this is a fairly shallow thread for a start. Being 32 TPI, it's not going to be a deep thread, particularly in 3/8. So yeah, when you drill your hole for the thread for the tap to go into, you have to make sure you use a correctly sized drill. And this is where not all drills are the same, you know. I mean, there are big variations. That's why, you know, people go by thread charts, but quite often thread charts aren't actually all that accurate, really, because there's a variation in drill sizes. You might pick up a drill which is, you know, 5/16, but this is actually a 5/16. If you measure it, you'll find quite often it's not. You know, it could be quite a bit. It could be 10% either way. I mean, measure your drills with your micrometer, your drill sets, you'll get a big surprise when you see what they actually are. They're not always the nominal size. In fact, they're rarely the nominal size, particularly if they're the cheaper ones, you know, cheaper sets. So anyway, what am I saying? Well, when you machine this up, there's a couple of things you need to know. First off, we'll measure the dash pot, and we'll see what the actual thread diameter of that is. 9.33. .3 9.327, that's more like it. Yeah, so it's basically 9.3. Now, the problem you've got is that when you machine the rod to size, 9.3, we would machine this blank, I suppose you call it, down to. Now, if you machine it with a single point thread at that size, what's going to happen is it's going to be too big, because even though this is the same size as the thread diameter, when you do single point cutting, and it varies with the metal how much is going to happen, not only are you cutting, but you're also compressing, and metal will move around, and basically what will happen is the thread will grow. The diameter of the thread after cutting will be larger than what you started with. So that means that basically the thread that you cut will be too large. So you have to reduce the diameter of your starting blank to compensate. So whereas we were starting with 9.3 mil, I reduced it back to 9 mil after the first one I made was too sloppy for my liking. And at 9 mil, it then cut a 9.3 mil diameter thread. So basically, you got 9 mil here and you got 9.3 there. So it's a perfect thread. So that's what you have to watch out for. Also, when you do your single pointing, make sure you've got the angle of the thread gully correct. This thread is a 40-degree thread by my measurement. Normally they're 60. That's the most common thread angle. So I had to grind a special single point cutter to do the job. But basically that's it. It's very, very, very simple to make these up. Anybody can do it. And of course, you know, you just grind your flats on with, you just use your bench grinder. I mean, nothing very, very flash about the whole thing. So there you have it. So yeah, if you want to make a tap up for a one-off job and you don't want to spend money, you want to be tight like me, this is how you do it. All right, well I hope you got something out of that. Just show you a couple of things to be aware of, and yeah, get into it, do it. And now it's just going to be Sterling engines ahoy and full steam ahead. All right, that's it from me. See you next time. Cheers.